Hey everyone, welcome to our Experimentation 101 webinar. It's so great to meet all of you virtually, and I'm really excited for this session. Good morning, good afternoon, wherever you're joining us from. I'm Sid from the product marketing team at Statsig, and today our presenter is our very own data scientist, YZ, who's going to be talking about a lot of great actionable insights that's going to help you build and implement a scalable experimentation program at your organizations. As we have more people trickle in, let me just get a couple of quick housekeeping items out of the way before I hand it over to YZ. So the first is that this session is being recorded, and we'll also be sharing with you the slide deck and the recording in a few days after the webinar. And the second is that we have a lot of great follow-up resources that you can take advantage of to continue, reading about the subject and just learning more about what we are doing at Statsig and getting up to speed on that. So during the session, I'm going to send you some resources like joining our Slack community, registering for a product demo that's happening next week, some case studies and blogs that you can check out as well. So do engage with us on the chat. I've enabled the meeting chat and Q&A, so you can also keep your questions coming in throughout the session. And in about, we'll set aside the last 15 minutes of today's session to answer some of those questions live. So I'll compile them throughout YZ's presentation. And then, the last 15 minutes, I can ask him a few of those questions and have him answer it live. But like I said, there are all these other resources as well that you can take advantage of. So I'll keep sharing those on the chat, and we can continue the conversation even after today's webinar. So without further ado, it's great to see, hundreds of you joining in today. So really, really glad we can engage with the data community this evening. We're joining, of course, from the Pacific Northwest in Seattle, and I think we have an audience that's really from across the entire globe. So let us know where you're from on the live chat. And without further ado, over to YZ for the presentation.
All right, thank you, Sid. And just make sure we encourage people to ask questions in the Q&A, right? Not in the chat. Yeah, so if you have questions, ask them in the Q&A function in Zoom. All right, thank you everyone for being here. Today I'm going to talk about experimentation 101. And as you can see, there is a scalable experimentation. Because the webinar is mostly broadcast in my personal network, so I assume a lot of you are familiar with me, so I will skip my self-introduction. But the reason I do scalable experimentation is because scalable experimentation is really fundamentally different from A/B testing, not in terms of methodology. The methodologies are the same. Actually, scalable experimentation are usually easier or simpler, at least we strive for transparency in the experimentation. But it is a completely different infrastructure and different culture, different practices, and different use. So I'm going to talk about that part of the experimentation in this webinar. Okay, so the agenda of today, I think I have about 25 slides to share, and three sections. The first one is why do we do experiment? And it's somehow not very obvious. Like people have different reasons to do experiments, but the big reason is we don't know how often we are wrong. And in order to have compound growth, we need to do experimentation. I'll talk about the motivation behind it. And two, I'm going to emphasize on introducing what is a scalable experimentation and what is the infrastructure that enable that, and some key insights. There is a key technical insight that enables scalable experimentation. And the third one is about culture. You won't have a successful experiments without a good culture. So let's go into the first one. This concept of you are what you measure. That is why we do experimentation. So that is a quote from a management guru decades ago, dozens of decades, a few dozen years ago. Yeah, you are what you measure. So this is actually from customer story of one of our customers. The customer is the Rec Room. For people who don't know, they are kind of a gaming company, and they did an experiment to change the experience of their lobby. So this is the lobby. On the left is the old lobby, and on the right is the new designed lobby. And as you can easily see, this is a very nice design on the right. And if we don't have experimentation, if we ship this kind of improvement on the products, everyone should be celebrating, right? Changing from left to right is a big milestone, and they should be celebrated. But Rec Room use static, and they measure their key metrics. The hint is Rec Room is a social game. They care a lot about player interactions. So like from this picture, can you see if there is anything wrong with the picture, with the design on the right, to the right? I'm gonna pause for a few seconds. Like try to look at the design and see if there is any problem with this design. Okay, the answer is they track a few key metrics, and one of the most important metrics they track is this chat threads created. How many people message each other, how many people chat with each other. And it had a huge decrease. We cannot share the exact number here, but this one means it is statistically significantly negative. So the black bar is the mean, and the red bar is the confidence interval, and the confidence interval is well below 0%. It is a static decrease. So the new design caused a decrease in one of their key metrics. And once we have this learning, it's kind of obvious because message used to be very central, and people are used to the old UI. So when they want to message their friends, they'll just click here. But in the new UI, message is on the top right, and it's not immediately discoverable. It's not people's habit. So there are less messages created. So with the learning, the team went to the first iteration to make message bigger and more prominent. And the result is, if this is a daily view, the right line, the blue line, dark blue line is the mean, and the area is the confidence interval. So message increased, but still below 0%. So this is the average treatment effect. When they shipped the new improvement, it got better, but still static negative. So they did another iteration. They follow like this is when they there is something still wrong. We still need to do more design, and the shifted design and the new version, the V3, they made messaging very front and central. So the number of messages increased and was static positive. So in the end, this new version is a better design than the left one, but the original redesign was not. So instead of celebrating when you see a new design, you should really be questioning, like, is it really better? You cannot understand this without a measurement. And that is the point of doing experimentation. Doing experimentation means you try new things, but it also means you have to measure what is the result. So why experiment? This is from just mindlessly celebration to think about what really happens, to have questions, have curiosities, and doubt the immediate impact. Why? Because there is actually, this is a well-known kind of observed pattern that 80% of our hypotheses are wrong. So it was in books and it was in empirical studies. 80% of our hypotheses are actually wrong. And it's actually quite natural because the ecosystem is complex. So on the right, there was an old story or kind of old evidence that in the, I think, 1940s, United States used DDT to kill bugs in the field. But turned out it actually impacted egos, because the residual of this DDT gets concentrated in the food chain, and it actually poisoned ego and put ego almost to extinct. So initially, people have a good intention, but because the ecosystem is so complex that you have unintended consequences. And because we are doing hard things with our product, most our hypotheses should be wrong. Otherwise, we are just doing easy things. If everything is predictable, then it means we are doing things that are easy. So without experiments, we cannot internalize how often we are wrong. We don't know which ideas work and which ideas don't. We leave easy money on the table because sometimes, without experimentation, we don't get to try many things, and we can leave easy money on the table. There is also, examples of easy money on the table in the reference as well. And we miss out on compounding growth. So what do I mean by compounding growth? All startups wants compounding growth. Startup is growth. But in order to have compounding growth, you need to compound positive impact. Remember that 80% of the hypotheses do not go as planned. So in reality, your product metrics look like this. It is because you shipped many things. You shipped some positive changes, and then you ship something that's a regress, such as the Rec Room example. Maybe you have a well thought of design. You spend a lot of time, doing the product iteration, but for reasons that you cannot foresee, it actually regressed the metrics. And the stylized fact is most of the time it's not going to be as you expected. So if you have a measurement of what is positive, what is negative, by simply do not ship the negative features. So you are not doing anything extra. You just know which ones work, which ones don't, and you just abandon or kill the bad ideas. You will unlock the compounding growth. Otherwise, you will increase, decrease, increase, decrease. But here you can actually increase, don't do anything, increase, don't do anything. You can actually have compounding growth with time. So there is a famous saying at Facebook that do not mistake motion with progress. This is progress and this is motion. More product iteration is not necessarily good. Only positive product iteration are good. So some tenets of doing experimentation, and I think this is the fundamental principle of why experiment is the best way to develop product. These are 4 simple things that are kind of what I summarize as true axiom like in product development. So first, when you grow, there are more unknowns than knowns. The world is too large and too complex. There are more unknowns. The second one is you learn the unknowns by exploring as much as possible. So you cannot deduce, you cannot learn from the textbook. There is not many experiences you can learn from. You have to explore the unknowns to understand the unknowns. And the third one is to learn in exploration. You need to measure. Kind of goes to our previous examples. You need to measure in order to know if this works or doesn't work. And the fourth one is people can only learn after the fact. So kind of the natural conclusion is the best way to learn, to explore and learn and to grow is to experiment, create the fact, and then we learn. Then the second section is about scalable experimentation. This is kind of the thesis of this webinar, that people usually conflict. This is common, especially among data scientists who work as traditional industry, or data scientists who do not have more than infra in their product. So the typical A/B testing, the unscalable A/B testing is there is a demand to do A/B testing, to do experimentation. And the data scientists can come up with a list of users, a list of hypotheses, and then collaborate with the engineering team to set up the experiment. The engineers need to code the randomization and then code the 2 experiences. And the data scientists have to babysit the entire A/B testing to check if everything is balanced. Are we tracking? Are we logging correctly? And then everyone sits together and analyze the results. If it's good and ship the experiment, the engineers have to go back to the code and do another maintenance to actually ship the experiment. So there is a big effort to set up and maintain, and you can only test a few metrics. The more metrics you test, the complexity just grows exponentially, and it takes a long time to read. Then there is indirect impact on the product because you first set up the A/B testing, you do the learning, and you tell engineers, everyone discuss, and then with the discussion, you make a decision on the product. But scalable experimentation. So this is the practice, I think, started with Google, Meta, and then a lot of modern companies, and today, like Notion, Figma, OpenAI, they all use this. They run hundreds or thousands of experiments every day. And these experiments cost little effort to set up and maintain. In fact, they only cost 2 lines of code to set up. We can test comprehensive metrics because additional metrics do not make things harder. I'll talk about why soon, but this is one of the benefits of having scalable experimentation. And then it only takes weeks to get a decision of shall we ship the experiment or shall we abandon the experiment. It is very direct impact on the product because the experimental result is the actual product that you are shipping. So you are making decision on the actual product, and with a click of a button, you can decide to ship or kill this product iteration. And to get from unscalable A/B testing to scalable experimentation, the big paradigm shift is you go from default off to default on. So in unscalable A/B testing, the default is you don't do A/B testing unless people ask you to do A/B testing. In scalable experimentation, the default is you experiment on everything, or you have the option to experiment on everything. Everything is already an experiment. You just choose to analyze which one. So the default is on. And this is from one of our customers that, before they adopt to Static, and at the start, when they adopt to Static, the whole company is running 73 experiments. And after, I think this is a year, a little bit more than a year, it increased to over 1,600 experiments. So that is the scalable experimentation at play in reality. And the number of experiments is the speed of our innovation, because more experiments means more explorations, more tryings, more iterations. So this number really represents how many product iterations you are trying in your company. So to do a scalable experimentation, we need scalable infrastructure. I took screenshots from Mr. Beast's video. He built 1,000 wells, 100 wells in Africa. So before you build the modern well, you have to have human to go to a pond or go to a distant water source to get water, fresh water. But with a scalable infrastructure, you can just get water and tap water automatically. So on the left, it's really a good analogy of traditional A/B testing. A/B testing is easy. A/B testing is just setting up the treatment group and control group. But if you do it for every product change, you are just fetching water from a pond. You don't have the infrastructure to support scalable experimentation. But another thing to call out is scalable experimentation is not to experiment everything. So the option is from default off to default on, but default on doesn't mean you should experiment everything. It just means experiment velocity is no longer a bottleneck. You can choose to experiment as much as you want to, but you still need to test good ideas. you shouldn't just randomly generate ideas and try which ones work. You should still be very thoughtful about your product development, but you have the option to experiment any feature change with little implementation cost. Just like when you have the well, you don't keep the water running all the time. You know when to shut down the water, but you have the option to turn the water on when you want to. And to summarize a few necessary conditions for scalable experimentation infrastructure, for people who have scalable experimentation infrastructure, they know everything, all these things are there. But for people who do not have the scalable infrastructure, this will seem almost, I don't know, almost fake. So you can check your own organization, like which one it is. So for organizations with scalable experimentation infrastructure, you can define metrics once and use them everywhere. So only need to do one definition. And each time when you do new experiments or dashboard or whatever that you need to use metrics, you can just call that metric. You don't need to define it multiple times. 2 is reliable and transparent semantic layer. So the definition of semantic layer is kind of the centralized definition of the metrics. And this centralized definition of the metrics is reliable. Reliable means the business definition to the table, to the code are really visible and transparent, and everyone can see and understand and debug the definition of metrics. So people have trust on the metrics. The third one is build, test, and ship the same code. So when engineers build a new feature, they can just build the feature and then conditionally open to some people and then test this feature and then ship the feature. And all these actions are on the same code. They don't need to develop different code for experiment and then for the actual product. They just need to change the dial to change how many people can see the feature, but it's the same code. They don't need to do additional development. The first one is build in experimentation culture and process in the product, in the console. So wherever people make decisions, read the experiment results, the culture and process of decision making should be on the console, should be in the product of people seeing the result. Based on intentfully display of layer information, because the experimental result is really there to make product decisions. So you don't want to throw all the information, vomit all the information to the decision maker. You want to have intentful display of what is important, what are the things you need to track and guardrail. Sixth one is trustworthy and practical stats engine. So you don't want to do fancy math. You actually want to have reliable math that people can understand. So people can really have confidence in their decision. They understand why they are making certain decisions. It never comes from a black box of algorithm. The seventh one is you should automate as much as possible. So everything here says this one line. Scalable experimentation is really about better product decisions. It's never about fancy experiments, fancy techniques. It's about better product decisions. The key insight. So I was actually hesitant putting up this slide because I think this is the secret of why we can do the scalable experimentation. If there is a competitor and they see this slide, they should understand the technical insight and build a product similar to us. But I mean, since it's so important, I still decide maybe we should share it. So the technical insight is experiments is feature toggles plus randomization. For people who didn't hear about feature toggles, sometimes we call them feature flags, sometimes we call them feature gates. It is really a conditional control of who can see your feature. It is as simple as if I satisfy certain condition. For example, if my email is in certain, if I'm a Gmail user, if I'm working in the company, if I'm an employee. If my country is US, then I go to experience A. If not, then I go to experience B, so I can control. And I can use the console to easily control, like who see the new experience, who see the old experience. And I can control the percentage of allocation in the console as well. Then experiment is really feature flags plus randomization. So from the feature flags, you already created the treatment, and then you have randomization and you monitor the metrics, you get experiments right away. Feature flags is already the best practices, the default best practice for engineers. So modern companies, engineers are already using feature flags as default. So if you just add randomization metrics, you get experiments as default. Experiments really is the native citizen in product development. So simple as this, like people already are using feature flags, and you just add randomization and metrics, you get default on scalable experimentation. But in order to do experimentation well, it's mostly about the culture. So when I talk about experiments with data scientists, people are often frustrated with the org's data-driven culture. So people pay lip service to data-driven, but actually not. So for example, in a lot of companies, there is this bad culture of analysis paralysis. People want to reach consensus before they can build anything. But the problem is, if you didn't build this, there is no analysis can tell you what's going to happen. Nobody has a crystal ball, and as I mentioned before, modern ecosystem, modern product are complex. We pretend that we can predict future, but we cannot. So the way to see if our new initiative can work is to really build it and read the result. We are going to share the deck, and in the deck, I shared a very nice story from Duolingo. Duolingo has a strong experimentation culture, and just test it, just build it, and the conditional and open exposure so people can see, and the impact is controlled, and then just monitor and measure. There is another great book, very nice book, Greatness Cannot Be Planned, that explains why you cannot predict the future. And there is this story about why more trying gives you more opportunities. So if you want to develop your product, you should really try more. That is kind of the best thing you can do to make sure you have more opportunities and more growth. The other culture is celebrate learnings. So when you do the first experiment, it can be very humbling because you have the hypothesis, you have the conviction that your hypothesis is going to work. You have all the reasons to convince you and your shareholders that my experiment is worth trying because it's going to be successful. And then it doesn't go your way. Remember, like I said earlier, 80% of our experiments fail, or 80% of our hypotheses fail. It is actually pretty natural that it's almost guaranteed you are going to have more failure than success. But when you see the failure, your first instinct is to change the narrative. Either find some data that my experiment did not fail. So this meme on the left is the test is bad, but I can try to find for subsample that it works. Don't do this. And the other kind of instinct is I change my narrative before I'm confident that this will work. After seeing the results, I try to explain why at the beginning I thought this is not going to work and everything goes as predicted. But if you have this kind of mentality, you can never learn. So you really need to accept that you are going to fail, and you really need to remember your initial hypothesis that you can build intellectual honesty. And once you have intellectual honesty, you can actually objectively learn from the experiment and really do better. So when your experiment fail, you should learn from these failures. There is a saying that there is no failure, there is only success or learning. But the real failure is you fail to learn. So product development should be deliberate, and the day you stop learning is the day you stop growing. The next one, I think, is pretty obvious from the Rec Room example. Good ideas actually take iteration. So when your first idea doesn't work, or even when your first idea works, you should still think about, is there a way to do better? And almost guaranteed there is a better way. Because you cannot predict future, so you cannot go to the optimal solution right away. You need to learn from the experimental results and try to do more iterations and do better. The implicit culture that goes against this is the highest paid people's opinion. So this is actually an objective saying. This is, I think, the CEO of AOL. If we have data, let's look at data. If all we have are opinions, let's go with mine. So data is really kind of the foundation of truth. Without data, it's going to be whoever has the highest income that holds the truth. And often it's not the right instinct. So that is the end of the body of my presentation. Feel free to drop questions in Q&A. We have some additional learnings that I want to cover the questions before I go to this learning. So there are more resources. For example, if you have questions, long-term questions, join our Slack community, and we can answer those questions in Slack. We have blogs about information and important topics, such as Cupid, Bayesian, sequential testing, switchback testing, like those important topics that you need to learn about. If you are interested in seeing a demo or learning about the product, we have a content executive you can reach out to. We have a YouTube channel for data scientists' practical tips and knowledge. And then there are some articles about how to do scalable experimentation.
Yeah, some great resources there. Thanks so much, YZ, for the presentation. I've also been sharing some of these links handy on the chat, so do check them out if you want to, access some of that material. And a lot of people have been asking if we will be sharing the deck, to which the answer is yes, we will. So just give us maybe a day or two, and our team will be sending both the recording of today's presentation as well as YZ's slide deck to all of you. We've been getting a lot of great questions. I've tried to compile some of them. So YZ, if I read out some of these questions, maybe we can just quickly get to as many as we can.
Sure.
So my first question is from Dennis Gao. Dennis's question is, how do you determine the length of the experiment? We always tend to be perfect the performance, but sometimes we will lead to overspent resources on an experiment. So how do we balance that? Do you want to share some insights into that?
Of course, yeah. Can you see my screen?
Yeah, we can see your screen. Yeah.
Yeah, trying to. So in static, we have the power calculator, but let me just answer in concept. People linger in insignificant experiments for too long because they hope their experiment is going to turn statistically significant, and that is wrong, right? If our experiment is not significant, most of the time it's because our idea are not working. You don't have a working idea. You should revisit your idea and do iterations, right? This one, like this example, the result is static negative, but if it's static neutral, you should still revisit your idea. But to calculate the duration, the disciplined way is to calculate before the experiment. So everyone should sit together and talk about the minimal detectable delta. So maybe I should use the power calculator. Yeah. So you need to talk about minimal detectable effect. Like for example, is it 3%? Are we going to like do we expect our feature to increase our key metrics by at least 5%? And then we calculate what is the minimum detectable delta. And from there, we have our historical information. So we have the variance of our data. We can use a standard alpha and beta to calculate the power we need for that experiment. I think we may actually, yeah. The recommendation is just use a 95% confidence interval. And you should be able to see like how many sample, how long is the duration that I need to reach that minimum detectable delta. And if you reach the duration and the result is not static, then you should consider abandoning the experiment because you want to save your experiment to bigger potential feature development.
Yeah, thanks for the question, Dennis. That's, I think, a really good, important thing to bring up. Next question is from Jin Lin. Jin's question is, often in one product release or deployment, we change multiple things or features. In this case, how can we independently measure the impact of a single change? Do you want to give some insight into that, YZ?
Yeah, I think this is also not the default. When you do the unscalable A/B testing, you release everything at once, and it's very difficult to disentangle. But with the scalable experimentation and with the modern feature flags, you actually do incrementally develop. Like every feature is its own test, so you can separate each feature, and you don't release many things at once. You release one iteration at once. Every day you are continuously developing and shipping. Yeah, for like companies like Facebook, ChatGPT, they don't release like every production. They don't bundle release. They release every day.
Yeah.
Yeah, if you have that infrastructure, then it becomes very easy.
Yeah, and we see that a lot with our own customers. And I shared, on the chat, some of our customer case studies, and these are some of the leading product companies. So, you can get some insight into like how companies are actually just releasing things every day and experimenting. That great question, though. Thanks so much for asking. My next question is from Anonymous. The question is, if your company only runs a small number of experiments, how do you convince the data scientists to go from unscalable testing to scalable testing? Also related to the question is, how do you emphasize the importance of scalability when your company does not run many experiments to begin with? Any insights on like how that, you can drive that culture, YZ?
First of all, I don't think it's data scientists as a blocker. It's the entire product development team. And talk about the best practices. It's really a team play. And a good experimentation culture actually comes from the engineering team. Engineers want to do experiments, and data scientists are willing to support that. I think in most of my experiences, maybe sometimes data scientists do not want to support many testing precisely because you don't have the infra. So with each additional A/B testing, it's a lot of overhead for data scientists. Maybe that is why. But with a scalable A/B testing, we can show our product demo maybe in the next webinar as well. Every check is automated, and like it's very easy to read the number. Data scientists do not need to do the calculation. They can just help interpret the result. So they are fully supportive of running more testing. They don't support running more testing when they have to do a lot of calculation that eat up their bandwidth.
Yeah. Yeah, great question though. My next question is from Kaiji Chen, and the question is, how much developer effort is needed to implement feature toggles in a startup?
Not much. So here we have getting started. The document is pretty thorough. Once you set up, it only takes 2 lines of code. Before you set up, it takes maybe an engineer 2-3 days to set up. Yep. For actually most startup use static for feature flags. Only sophisticated startup use static for experiments, because most startups, they have engineers, but they don't have a lot of data people. So they need a feature flag solution. So they use feature flags and then do a light monitoring of how the feature change user experience or
And,
user.
and it's probably also going to be free. Sorry to cut you off, YZ, but it's probably going to be free for the startup to use. We have unlimited feature flags for at that scale. So, please take advantage of that. It's a low effort and it's also free. So it's almost like a no-brainer to start using it. The next question is from Peter Lin. The question is, am I able to use StatSig for Mac-based and Windows-based software experiments, or is it for web services only? So even though this is like a StatSig specific question, I think YZ, you can also just add some color into like being able to experiment on like all the different surfaces where in scalable experimentation.
Yeah, the simple answer is yes. And as you can see, we have many different SDK. I didn't go into detail with how we enable feature flags. So how we enable feature flags is using SDK or API, or we get it connect to our data warehouse to help you run experimentation, do the experiment calculation. But suppose you are a developer and you want to track your user across different devices, mobile, PC, and web. Then you install the SDK, and the SDK can help you generate logging and send data back to Static for calculation, and do feature flags to control the user experience. This gives you this document gives you everything you need to know. And you can see we support SDK in many different languages.
Nice. I have a few more interesting questions. I think do we have the time to just continue taking a few more, YZ?
Yeah.
Yeah. Okay. So the next question is, on quantifying the long-term effects of experiments, like months after the experiment ended. I saw a couple of questions along that lines. Also like on how to determine the length of the experiment. So can you just share some insights into that?
Yeah, determining the length of experiment, I think the trade-off is if your data is more noisy, then you need longer experiment. If you are detecting a smaller effect, if your minimum detectable delta is small, then you need longer experiment. If your number of users is small, then you need a longer experiment. I think yeah. Oh wait, sorry, it's not this one. Yeah, so we can share this in email or in chat as well, Sid.
Yeah, I can do that. Yeah.
Yeah, so this gives you kind of a relationship of how many users you have and how many power you can have from that sample of users. And the longer you run, the more power you have. But actually, the effects, the power, the incremental power from longer experiment decrease pretty sharply. Like running longer would not give you 100% more power. It can give you like 30% more power. So if your experiment is underpowered, especially for early startups, and I think there is a question about B2B experiment as well. When a sample size is small, you can still detect large incrementals Like for example, if you have 10K daily active user, you can still detect 6.5% delta. But if your improvement is only 1%, you need a much larger sample size. But for early startups, I don't think you are aiming for the 1% incremental. You are aiming for the 10% incremental, and that can be detected. This post shows you how to calculate. And don't run too long. I think 2 weeks of experiment should be more common than 2 months of experiments. Most experiments should be just 2 weeks.
Yeah, I just shared the blog as well, so you can read that on the chat. It also kind of talks about the answer to a previous question, which is the title of the blog is you don't need a million users to experiment. So even if you're a smaller company, you can definitely take advantage of it. Okay, I have the next question is, can you tell me more about randomization? If you have the feature flag, how are you going to do the randomization? Like when, where, and who to be randomly split?
Oh, good question. So when you do feature flags, so maybe it's actually easier to see with a demo. Okay. So this is our product, the console. And in feature flags, for example, this is a feature flag to determine who sees a larger product image, right? And the feature flag, I want to monitor a couple metrics, and I want to set up the rule. Like for example, 100% of the employee. So this is our company email. If our company email is this, it means you are an employee, you pass 100%. If you are early access user, you pass 100%. If you are United States or Canada, you pass 90%. So only 90% of these people see, and everyone else pass 10%. And you can already compare the delta of the two groups, right? There are people who pass versus people who fail, and you can get a kind of a matrix lift from this. And if you want to turn this into an experiment, you can sort of use the same gate. Or you can, for example, this is an experiment to show notification. You set up the experiment of, there are some users, not all experiments should be set up the same way. You want to trigger your events at a reasonable triggering point. So for example, for people who you don't want to test on everyone who went to your website. Maybe you want to test all the users who went to a product detail page or who clicked add to cart. And for the 100% of user who clicked add to cart, I randomly sent 50% to the test experience and 50% to the control experience. And then I go to the result reading and I see, okay, 50% goes to test, 50% goes to control, and I read the results.
Nice. I see a lot of questions actually based like about the product and about the Statsig platform. Some questions around, the capabilities and also how we are differentiated versus competitors. Just calling out that we do a monthly demo every third Thursday of the month. So April's demo is happening next Thursday. That is April 18th. And I have already shared the link on the chat. So if you want a more Statsig specific overview for 30 minutes, be sure to attend that. But because we've had a lot of questions, maybe like YZ, just at a high level, if I just summarize, the different kinds of questions we've got, people are asking like, is Statsig more of an experimentation tool or is it a product analytics tool? And also, how are we, I don't want to like call out specific competitors, but maybe just in general in the competitive landscape, how are we differentiated to some of the other vendors out there? Any high level insight you can share on that?
Yeah. So first of all, I don't think it's experimentation versus product analytics. Experimentation is the best weapon of product analytics. When I talk about product analytics, I talk about a group of people. I'm a data scientist who specializes in product analytics. So experimentation is really the best weapon there to build conviction, to be data-driven. But we also have different tools, right? Dashboard. I didn't mention this in my, because I want to focus on scalable experimentation. But like you define the metrics already in Static. Like the metrics you have, this is the semantic layer I talk about. For example, you can define, we want to do aggregation. I want to aggregate events and I want to sum the event, right? I can sum the value and I can do a time window. Or I can do a funnel. I can define ratio. Then these ratios can be used in experiments and as a dashboard. So you can drag the same metrics to dashboard, for example, or to show in experiment and see, or even link experiment to dashboard. So that's why I think experiments and product analytics are really the same. And you should use all the weapons to understand the product and help product make decisions. Often you come up with hypotheses by analyzing, and you get a causal answer by experimentation.
Yeah.
About how there are many competitors. There are many competitors, but some competitors, such as LaunchDarkly Split, they are doing feature facts. Some competitors like Apple, they do experimentation. But the integration of, so first of all, the experimentation centered around product development, I think we are pretty unique. The scalable experimentation centered around product decisions. We are pretty unique in that. Yeah, I think I need the question to be more specific to answer. Like, what I do? Why are we different? Because of course we are different. We are like every way different. But unless there is a more specific answer, it's very hard to cover everything.
Yeah, no, that's fair. I think the ability that, Statsig has all these three really powerful tools within a single platform. And also I think, proven scalable results, right? Like we have companies like OpenAI using us and hundreds, if not thousands of like small startups. So it's like really serving like the entire spectrum. So I'd also recommend if people are like evaluating different vendors to like, go to the resources that YZ is pointing to. And, we have some customer stories that are published and you kind of see like a whole range of, logos out there that are using Statsig. So, yeah, but definitely if you have more specific questions on like, how we are differentiated on a specific capability with a competitor, we're definitely happy to engage and answer that offline. So yeah, but great questions though. I saw many questions on like, the competition or like just the different capabilities of Statsig. So I just thought I'd have YZ answer at a high level. I have one question from Amber who asks, how does scalable experimentation take the business impact into consideration? For example, even when the A/B testing results is significant, the business value of this feature is relatively low compared to the cost of implementation. Do you have any insights into that, YZ?
First of all, the implementation should be relatively cheap. Like when I hear people say, implementation is too expensive, I read that as a signal of the infra is not good enough. Like if you have good enough infra and the culture, implementation should be cheap. But the other part of this question is data is not everything. So actually, I think talk about that here. Yeah, like there are a lot of, like for example, this is an example of you having a fake here and it increases CTR, but from a human it's very obvious that it's a bad experience. And I recommend this post. We can share that as well. It's Tom Cunningham. Experiments is not about automating decision making. Experiment is about measurement. we measure as much as possible. But the data scientist's job is to inference from the observed effects to the true effects. And remember, these are two different things. We can observe some metrics increase or decrease, but we still need to use our knowledge, qualitative understanding, our mental model, our analysis, the product decision, the roadmap, the strategies to decide the true effect of this feature on the product. And then we also need to do from short-term effect to long-term effect. So those are like the true problems true challenges that data scientists should address. We shouldn't just automate decision making.
Yeah, a great question though. Great question. Do you think, YZ, we have a time for a couple more questions?
I think we have two more questions.
Yeah, okay. So I like this question from Muya Wang. The question is, experiments overlap each other. How do you make sure that they don't affect each other?
Oh, nice one. They overlap with each other, and it's usually not a big deal. I think there is another recent article from Vista about this as well. So basically, in academia, people, I think, worry about this a lot. But in reality, it's actually okay. Like you shouldn't sacrifice too much of sample size interaction of experiments because it's randomization, right? Randomization should take care of a lot of things. Empirically, it's just not a big deal. They can, yeah, detect interaction effects in online experimentation. Also check this article. These are all like well thought of and with actual data. Yeah. It's okay to relax about it. They just do not observe this to be a big bias.
Okay. I guess the final question is like a nice maybe way to like tie it all together and just like reinforce what we discussed today. So Vignesh Raghavan asks, given that you can allocate say 50-50 traffic with feature gates, do you still need to use experiments?
In principle, like in theory, you don't need to, but in reality, you do. Because feature gates, yeah, like feature gates plus randomization plus metrics, like I showed earlier, is by definition an A/B testing. But we draw the distinction because engineers do not want to test everything, and they shouldn't do a full-fledged experiment on everything. So conceptually, it makes sense to separate feature flags and experiments and have a principle of what should be experiments and what should be feature flags. I think Ryan has an article about this as well. Yeah, the distinction between experiments and feature flags. Sid will send all these articles afterwards.
Yeah.
Then talk about when you should use one versus the other. And also in the product, experiments are more hypothesis driven, and you can do A/B/N test. You can have more than one variance. You can have a lot of configurations. You can have sequential testing, Bayesian. You can do qubit adjustment. You can do switchback testing. So there are a lot more complex or sophisticated feature for experiments that you should use that are not available for feature flags.
Yeah, that's a great blog. I'm just like sharing the link on the chat as well. Great question though. And I think this blog is a helpful resource to like just make that distinction between the two. Okay, I think we are at time. Thank you all so much for some really great questions, engagement throughout the webinar, and just sticking with us till the very end. Really means a lot to see that kind of participation today. I'm also just dropping, I know we tried our best to answer as many of the questions as possible. But if you want to continue the conversation, I'm just dropping our Slack community join link. So you can join our Slack community immediately and, engage with thousands of experimentation professionals like yourselves. And we also have our team on the community. So we are also there to answer some of your questions. It's also a great way to just stay up to date on like what we're building at StatSig, upcoming events, product launches, and so on. And like I said, we have our monthly demo, which is happening next Thursday, April 18th at 10 a.m. Pacific time. So that's also a great advantage, resource you can take advantage of if you want a more hands-on product overview session. That's hosted by one of our solutions engineers. So you can also go deeper into, learning a bit about like how to set things up and like, even if you're recently started using StatSig, it's a great opportunity to, successfully onboard and set yourself up for success. Any last thoughts, Wisely, before we wrap up?
No, thank you everyone for coming. And this is for data scientists. Like A/B testing or experimentation is so important in our skill set. And the only way to be better at doing this is to do more. I think that is like more comes from, better comes from more practices. So yeah, do more experiments.
Yeah. And at StatSig, we move fast to help you move faster. So do take advantage of the StatSig platform as well. And we hope to keep you, keep the conversation going after the webinar. So thank you all so much for joining us today. And bye for now.
Bye.